Hi everyone, my name's Jenny Stenhouse and this is the first episode of our Augment Your Senses series. Today we're going to be focusing on a little bit of biology. So let's look at what a sense is. Here's what Wikipedia has to say about it. A sense is a biological system used by an organism for sensation, the process of gathering information about the world and responding to it. So it's always a bit annoying when the word you're trying to define is being used in the definition, but we can pull the important information out of this. So system is key here, along with gathering information and responding. Let's look at a generalized example. Our sense organ here takes stimuli from the world, turns it into electric impulse that the brain can understand, and then passes it along to the brain. In this case, the brain does the heavy lifting of interpreting the data, then taking some action or response. If we try to make it as basic as possible, a sense is the system that takes inputs and turns them into outputs that can be responded to. Let's work through a couple more definitions. Umwelt. This strange word describes the perception of the world as it is experienced by a particular organism. This perception is influenced by the senses that you have available and your ability to process the inputs from the world. So they differ greatly between organisms. A bacteria's umwelt is very different to yours. Sensory organs. Okay, these are what pick up the stimuli from the environment or from within the body. There is a huge range of sensory organs across the animal world, and they differ not only in density, but what they detect and where they detect it. Let's take a look at a couple of examples. So sharks have electroreception. They have tiny pores across their body that are extremely sensitive and can detect even the faintest of electrical fields, such as those generated by the Earth's geomagnetic field or muscle contractions in prey. So noses, we're familiar with those. Dogs have around 300 million olfactory receptors compared to humans who only have around 400. Bees use ultraviolet vision, antennae for touch, and their whole bodies for sound reception. Sensory receptors have been evolutionarily tuned to pick up specific types of information, which have been deemed useful over time. You can really see this in the bat's ear shape. With humans, we also tend to talk about sight, smell, taste, touch, and hearing. Well, we actually come equipped with a whole range of other senses, like proprioception, your body's ability to sense movement, action, and location, like where your limbs are in relationship to your core. And there's a range of interoceptive senses, which are the signals from your internal organs, including your cardiovascular system, your gut, your bladder, and your kidneys. In a way, it's easier for us to discuss what a sense isn't. It isn't just your sensory organs, and it's not notifications about what's happening around you. It's more about the system and the incorporation of the sensory data into your life, decision-making, and thought processes and reactions. Let's talk about neuroplasticity. Neuroplasticity is the capacity of neurons and neural networks in the brain to change their connections and behavior in response to new information, sensory stimulation, development, damage, or dysfunction. When first coined way back in 1948 by Polish neuroscientist Jerzy Kornowski, plastic was a really good example of something that was malleable and that could be formed in multiple ways. However, it may be a bit limiting. Dr. David Eagleman uses the term live wired to encapsulate the myriad of ways that a brain can be reconfigured and adjust and adapt to optimize its function. These new pathways and connections don't form instantly. Each new pathway needs to be reinforced to be maintained and kept. This is the idea of use it or lose it. There needs to be some value to the brain, a feedback loop, to deem this series of synaptic connections valuable enough to be maintained. This is important to remember when creating your own sensory substitution solutions. The brain is excellent at optimizing. If the feedback loop isn't valuable, it will prune it out in favor of using that real estate for something else. In Livewire, Dr. Eagleman proposes a plug-and-play way of thinking about sensory inputs. Your brain doesn't know and doesn't really care where the data comes from. It just works out how to best leverage the information. Mother Nature can build new senses simply by building new peripherals. In other words, once she's figured out that the operating principles of the brain, she can tinker around with different sorts of input channels to pick up different energy sources from the world. Information carried by the reflection of electromagnetic radiation is captured by the photon detectors in the eyes. Air compression waves are captured by the sound detectors in the ears. Heat and texture information is gathered by the large sheets of sensory material we call skin. Chemical signatures are sniffed or licked up by the nose or tongue, and it all gets translated into spikes running around in the dark vault of the skull. I love this quote from Livewire. It highlights that no matter how the information enters our sensory organs, it ends up as electrical impulses in the brain. The potato head model is another way to think about the notion of plug and play. You could take out the eyes and attach the input to the skin, or add in an ultrasonic sensor that utilizes the pathways of the ear. This ability to swap out the data inputs and know that our brains can figure out what to do with this data, as long as it's important enough, is what we can leverage to augment, substitute, and add new sensors.